later on, they can just come on in. So today we're going to be talking about a little bit about Clojure, Boot, and Hoplon. So this is going to be a little bit of a crash course introduction into Clojure itself. Now Clojure is kind of a newer programming language that's gaining a lot of popularity and is making things in the business world a lot easier. So if you don't already know about Clojure, it is something that is becoming a lot more popular, and a lot of businesses are starting to look at as a requirement for programming. If you're looking for positions that specialize more in the business side of programming world as opposed to like more web-based stuff. So first off, a couple of the topics that we're going to cover is the 3 different versions of Clojure. So Clojure, ClojureScript, and Clojure for the CLR. We're going to talk a little bit about building applications for Clojure with Boot, the Google Clojure compiler, as well as making web apps and a couple of cool resources. And we're going to go into building a demo app. And the demo app that we're going to be building is actually the FreeCodeCamp app. We're going to convert it from the React app that it is right now into a Clojure app and show you how quickly and easily you can do that. And you can do pretty much the exact same thing in terms of functionality in a fraction of the code. So we're going to replace about 3 of the React files with about 20 lines of code of ClojureScript and show you how easy it is to do that. So first off, Clojure is a Lisp. So Lisps are a general programming language. It's actually a family of programming languages, and Clojure is one dialect within that family. Now Lisp has a really cool kind of uniqueness to it in that it's represented in parenthesized lists. So that essentially means everything, your data and your code, is all a list. So you have this really cool code as data duality that you get out of that, where at any time you can look at your data as programming code and actually execute it, or you can convert your code into data and manipulate it and work with it. So you get this ability to write programs that build programs instead of just directly building your solution, things like that. You get into more of a way of creating an algorithm to solve a problem instead of directly solving a problem, which is cool because you can reuse those algorithms when the problem changes, and you can still get a lot of really nice functionality out of that. So the 3 different versions of Clojure are all targeted for different kind of use cases and the different environments that you're going to run it in. Clojure is originally for the JVM, for the Java Virtual Machine, and then you have its variants, ClojureScript and Clojure CLR, which run in JavaScript and .NET respectively. So here is an example of what some Clojure looks like. So this it starts off with your opening and closing brackets. Those are your little parenthesized list, and then the first character or the first argument position is your operator and a series of operands. So this is exactly like how you'd have your function name and then a series of arguments that you pass to your function, and just like any other programming language. So if we wanted to do some basic math, here's an example of your opening and closing brackets, the addition operator, and then the arguments that you want to pass into it. So one of the nice things about this whole list structure is that at any given time, I can replace an argument for another set of S expressions, for another set of parenthesized list. So what this is going to do when it actually runs through the compiler is it's going to evaluate this inner form first before moving out to the outside form. So what you're going to get is 2 minus 1, which is 1 plus 2. So it has kind of this longer evaluation process, but it's all about the order of the operands that you pass together. So in every programming language, you have to have some type of way of storing values once you know how to execute them and kind of pull them together. So in this example, we're showing you how to store a variable. starting out with def as our function operator. So that's how you define something. The variable name that we want to use, and then the value that we want to set to that variable passed in at the end. So if we were to then call the variable, you see that we get the value from it right away. Now, so I've kind of shown you in these last two examples creating variables and then using operator functions against some arguments, against some variables. So what we're going to show you here is actually creating your own types of functions, right? No programming language is all that useful unless you get to create your own little bits of logic. So how we do that is the exact same way as we would with the variables. We use define, we create a symbol for the function name, and then we pass in a function, which is going to take 2 arguments and give us a string, which is the value of those 2 arguments. Now there's a shorthand for this called defend, which allows us to drop some of the brackets and just saves us on some of the typing. And it takes the exact same arguments, the function name, the arguments you pass to it, and then the body of the function, which is the actual code that you want it to execute. So if we went ahead and ran that, passing in 2 parts of a string, it gives us the output string at the bottom there. So before we move on, does anyone have any questions with the structure or anything that we've talked about so far? It's pretty straightforward.
Can you go on to this slide?
Yeah, sure.
So I see the first line is the definition of the function.
Yeah.
But I don't know how where the execution part comes in.
So in the first 2 lines here, the one at the top and then the middle line, these are both declaring the same function.
Yeah, it's a declaration of the function, but
yeah.
How it is turned to hello world with
Right, so that's the bottom here. So what we've done is we've put the variable name that we've created as the operator location, and that now calls it as a function. So, and then we're passing in these 2 partial strings here. So this is how we call the function that we've just created, is with your opening and closing parentheses, right? So that actually causes evaluation to happen on your function. Does that make sense? Yeah, we'll get into it a little more. It'll make more sense once we get into a bit of the coding examples, and you actually get to see how you use the different functions and stuff that you create. So in order to do any of that, we use a little tool called boot. Now boot itself is a Clojure application, and the nice thing about that is when you're building your program in the language that it's written in, you get the whole functionality of that language when you're building your application, right? Like you're not limited by any type of build tool in terms of what it's capable of doing. You've got the full range of expression of the language itself. So what boot does is it replaces a lot of the other build tools that a lot of other programming languages use, like NPM, Grunt, Bower, Composer, things like that. Now, one of the major differences about boot versus a lot of the other build tools that you usually use is that it doesn't care all about the project that you're building. A lot of build tools like NPM make you specify the name of your project, some version information, some in and out files, all that kind of stuff. Boot kind of skips a lot of that and only really cares about the dependencies that your environment needs and the file system, right? Because all of your programs, when you're building an application, are just bunches of files, with different extensions and things like that. Now, when boot runs, it has this idea of working on a temporary file set. So it's never actually working on your code itself. It's working on a temporary copy of your code. And the nice thing about that is you can declare what types of files you want in your output folder and which ones are just used during the build process itself. So it has a way of specifying that through input and output files. And those have a couple different associations. So you have your source files, which are usually things that get compiled but are never put into your output folder. You've got output files, which are usually things like CSS, images, assets that you normally wouldn't need except in the final project. And then you have resource files, which are both input and output files. So they're things that you include during your build and that you want in your final output as well. So Clojure script and the Google Clojure compiler. So again, this is a bit of a crash course into an introduction in the Clojure ecosystem. So don't worry if you don't pick up a lot from the presentation. The coding examples that we're going to get into explain things much more thoroughly. So ClojureScript itself runs on JavaScript. It runs inside your browser. It doesn't specifically get directly compiled to JavaScript. What actually happens is it gets compiled to a library called the Google Clojure library. And the Google Clojure library is a JavaScript library that's used by tons of Google programs. It's actually what all of the Google front-end web apps are made out of. So things like Gmail, Google Calendars, Google Maps, all those really busy web applications are all built in the Google Clojure library. The Google Clojure library is then compiled using the Google Clojure compiler into really efficient JavaScript. So during this process, some of the optimizations that you get by doing this are code minimization as well as dead code analysis. So what happens is when your application gets compiled to the Google Clojure library and it gets compiled to its final JavaScript, it gets analyzed for all the bits of code that you don't need, and it strips all of that out of your application. So what you're left with is a really efficient, really small package that gets sent to your client's web browser and actually runs your application. And the nice thing about this whole process is that all of it is handled by the ClojureScript compiler. So you don't need to know about any of its workings or really anything internal to it. You just kind of need to know that this is the process that happens when you compile ClojureScript to JavaScript. It goes through a little intermediary step, which gives you a whole bunch of analysis functionality and efficiency and performance features that get bundled in there. And finally, Hoplon. So Hoplon is a web library that you run in ClojureScript. It's kind of like React in JavaScript or any other web framework that you'd usually use in other programming languages like Ruby on Rails or something like that. The difference between Hoplon and a lot of other web frameworks is that it's just a library. Web frameworks themselves try to give you a lot of functionality built into using the framework, but by doing that, it limits how you actually get to program your application, right? It's already kind of funneled you into a certain direction when you're building out your software. And Hoplon doesn't do that. It's a library, so you can pick and choose what parts of it you want to use. You can use all of it. You can use none of it. It's entirely up to the developer. Now, it has a very specific role in that it generates HTML5 and other ClojureScript. So you'll see when we actually work with the code examples that Hoplon files get their own little file extension, and all they really are is a ClojureScript file, but they've got a bunch of shortcuts built into it that we get to take advantage of. Now, Hoplon is part of a larger ecosystem that developers get to use when they kind of pull in its sister libraries, Javelin and Castra. We're not really going to get into Castra at all because of our demo application doesn't have a back end. It's only a front end, so we're not going to worry about communication between an API server and all that kind of stuff. And Javelin cells. So Javelin is a library that enables some spreadsheet data flow. And what that means is that if you think of an Excel spreadsheets usually have two types of cells. You either have an input cell, which has some type of data or value in it that you'd usually change, and then you have formula cells, which take a bunch of input cells, perform some type of calculation, and give you the result of that. So by working with these types of cells, we get kind of the functionality of life cycles and reactive systems that kind of propagate changes throughout the system automatically, and you don't have to worry about it at all. All you have to do is kind of work with these two little bits of data that Javelin gives you, and you get all this baked-in functionality right from it. So here's a couple of resources for you guys. This presentation is going to be available online, and Peter will probably be emailing it out to everybody that's on his FreeCodeCamp mailing list. So not going to worry too much about that. Again, these are the resources that you'd need in order to follow along with the code demos that we're going to get into. We're not going to do too much about installing the software and all that kind of stuff. This is kind of just an introduction to the workflow that you guys would be using if you were programming in Clojure and that kind of stuff. Yeah, so without any further ado, we'll get into that. So what I've got here is the FreeCodeCamp demo application that you guys were building last month and would have been continuing to build today. I've already gone through and got that running. And then what we've got underneath that is the React to Clojure script project folder. And that's going to house all of our Clojure files. And we're going to kind of show you the comparison between building these two applications and show you with a whole bunch of less code how you can do it in Clojure script. And hopefully that won't take too much time here. So what we've got in the React project file or project folder are your two basic boot files. So boot is our build tool, so that's kind of where we're gonna start off here. The first file that we're gonna go over is your build.boot file. So this file kind of shows you this file itself is actually run anytime your project starts up boot. So it scans for dependencies for your project and the environment, and then it builds a couple of tasks that your project gets to use. So boot itself has this task pipeline that works against that temporary file set that I was talking about before. And we're going to take a look at a little bit of that down at the bottom here. So this example kind of shows you how you can create tasks, which are really just a whole bunch of smaller tasks built together, which is a much more composable functionality than a lot of other build tools, which are really static, and you kind of have one task that you define how it works, and you're kind of reliant on that task. In boot, the whole idea is that you're building your own custom tasks based on your application's needs. So you're not ever really locked into the build tool. You can always just extend it and customize it and do whatever you want. And because it's a Clojure application, you do still get the full functionality of the Clojure programming language in order to do this. So the only two tasks that boot actually has built in that we're going to use are the watch task, which creates a file watcher. So anytime our project files change, it's going to rerun our little build process here. And then the target task, which actually outputs all of our build files that are marked as output to a directory that we're gonna look at afterwards. Now we've got a couple of other tasks in there that I'm not going to cover too in depth. Basically, the idea is that these are coming from third-party modules. So these aren't built-in boot functionality. These are modules that are specific to Hoplon and the Clojure script application that we're going to build. Okay, so the first set of files that we're going to start up you guys can't see that. Okay, so we've started up the boot develop task, which is that task that we just took a look at, and that's going to do a couple of things. First, it's going to connect up to the internet and fetch any dependencies that we might be missing from our system, right, from that environment file. Well, today it's going to give me an error. Oh, it's complaining about a missing file. So give me 1 second here. We're just gonna skip ahead a couple files. Oh, what's the problem here? So it's looking for the source folder. Did I spell that correctly? Sorry, guys. Doesn't help when my computer screen isn't updating. Okay. Hopefully this will work this time. Awesome. So right now it's checking for any dependencies that might be out of date. And then it's going to start up our development server so we can actually take a look at what project we're building. The internet's a little slow here at startup, so this might take an extra minute than what we're used to. Cool. So as you can see there, halfway through, what it's done is compiled the Clojure script file and has run, basically has gone through, scanned that the project files are all empty right now, and just compiled the Clojure script, or sorry, the Google Clojure library into a JavaScript file that you could pull into your projects and kind of use just as the library itself. And awesome. So it started us up a web development server. And what we're going to do is take a look at that. Okay. So this is the web server running here that we just started up. And as you can see, obviously we don't have any index page or anything else like that there. So it's giving us a 404 not found error. And what we're going to do is actually add some files to it. So we're going to create that index folder here. Oh, am I over here? Yes, so that's the FCC one. Awesome. Oh, no, that's not what I wanted. Here we go. So I'm just going to move forward a little bit. Awesome. So we've jumped forward in time in our repository here, but as you can see, since the project files changed, it started rebuilding, and we now have an index.html page and our index output. So what we've done in our project is actually add a index file. So we'll take a quick look at that. So the contents of our index file is, again, a little Clojure script function here. Page is provided by the Hoplon library itself, and then what page we wanted to output. So now that we've done that, if we take a look at the web browser again, well, let's bring that over here for some reason. We'll reload this. Cool, and now we've got a blank page because there's actually an index page there, but it's got no content. So we'll take a quick look at the source, and we'll see that what it's compiled is essentially a one file that's pulled in all of the Google Clojure library and all that kind of stuff. So this is all built into that compiler step that we just saw. So let's add some content to it real quick here. awesome. So it's going to rebuild. And as we can see, we'll go to the actual file here real quick. So we've added some content now. So all of these functions come from the Hoplon library. So what we've done is we've created an HTML bracket, we've created a head and body bracket, and then we put in some basic defaults from our template file, which came from public here. So you can take a look. The Clojure looks really similar to the HTML, right? Now, the nice thing that you're going to notice with the Clojure application compared to the React application is that React mixes a lot of JavaScript and HTML as you're building. And it does that in order to do some templating. But the problem is that you're now working with multiple languages, and you now have different languages outputting different languages, which kind of causes a lot of conflict and a lot of bugs that are really hard to track down in your application. With ClojureScript, everything is going to be ClojureScript. We're not going to have this mix of languages, or at least not anything that is going to be visible to the developer. So it's a lot easier for you to build and represent ideas when you're all working in one type of modeling system, right? In one type of language. So let's jump forward a little bit more. And we'll see, actually, we'll take a look at the desktop again. So we'll see that now we've reloaded the page and it's updated the body and head content to what we just inputted in that page there. And that's all automatic for us, right? We haven't had to work with HTML whatsoever yet, and everything's being auto-generated just based off the libraries that we're using. All right. Awesome. So we've started another build here, and this is going to fail on us. So in the React app that we have, one of the first things that you guys cover is routing. So we'll go over to the app page here. Yes. So one of the first things that you do when you're building your React app is you usually pull in the React router, right? So that you can have your single page app handle multiple different views or different aspects of your page. Now in Hoplon, we do the exact same thing. There are a bunch of user and community contributed libraries that handle routing for you. One of those things is the Hoplon, or is Biddy. So what we've done is we've added the Hoplon Biddy namespace to our file. And then we've added some basic routes and a route handler. So I'm not going to get in too much into the Biddy routes. Biddy has a really complex routing system that is able to handle a whole variety of different styles of routing. So you can basically build any type of views or any other type of routed system into your application that you want. So all we've done is cover some common use cases. So this will handle either no trailing slash or trailing slash and return the index page. Anything containing picture and then an ID will get routed to the picture handler, and then everything else will get routed to not found. So in this example, all we've done is use some basic data types in order to represent our routing, which is a much more dynamic system than just using regular expressions like you guys were in the React example over here, right? Where all the routing is handled by a regular expression call to dictate which page it's going to. So in order to build that, because we've added Biddy, we're actually going to have to shut this down and restart the develop task. And that's so that it can pull in the new dependency that we've just added to our application, which we didn't have before. So again, the internet here is a little slow sometimes, which I'm sure you guys have all experienced more than once. Cool. So we've started up the reload server. Now, one of the things I haven't mentioned before is one of the tasks that we're running as part of our development task is boot reload. And what that allows us to do is, as you can see here in our web browser, we've got this nice little error bar that has popped up across the bottom of the screen. That's part of boot reload. Now, when you change your project files and the build restarts, it's going to automatically send all the files that were changed back to your web browser and notify your web browser that those have changed. So you don't actually have to refresh your web browser page as you're developing things. It's going to update as you make your changes. As well, it's also going to throw these errors in a nice little status window anytime you have a problem. So as you can see in the console here, restart this. Oh, hasn't started up yet. Yeah, so it's still, right now it's just going through and compiling our new index page. And it's going to write all the output files and start up the server. So we'll refresh that. Awesome, so now we're getting a blank page again. So this is still kind of what we're expecting because we haven't actually put any real content into the body of the page. But what we can see is that in the body, we've added those routes. So it's handling the index page right now, and we can see that we're getting our app output. And we'll just go back to the code here. So right now, all we're doing for each of our 3 different types of pages is setting a very basic div for each one of those views, right? Nothing too complicated going on there. So I'm gonna jump ahead another quick time here. And we're gonna add some CSS files, and we're gonna actually make this index page hold some content. So awesome. So that started up a build because our project files changed again. And as you can see right in the web browser, without actually reloading the page, everything has already been updated with the new code that we've just automatically added to our index page. So, all right. So what we've done is in our React project, we've added this home namespace. So this is designed to mirror, oh, I'll drag this over here. This is designed to mirror our home JS file. So as you can see, a lot of the HTML was just copy and pasted right out of it, and then we just changed the brackets, right? Clojure, when you use Hoplon with Clojure script, it's giving you all of the HTML elements as an actual Clojure script function. So your structure mirrors your web app almost identically, right? What's in your code should be identical to the output of the application that gets compiled, without you having to worry about mixing HTML and JavaScript and all that kind of stuff, right? It's all handled by the actual web application itself. So what we've done up here is we've shown 2 different ways of passing in classes to the HTML that gets generated at the end. The first being some Clojure data types, which use a vector, which is essentially like an array in any other programming language, and then some keywords, which get converted to their string equivalent by Hoplon. And then we've also shown the option of just passing a direct string in. So because of this this nice feature where it'll automatically handle whatever type of input you pass to it. You get the ability to mix either data type, really. Now, when you are using more advanced data types, and we'll look at that in a couple minutes, like the lists, you get this ability to add items to it programmatically, and it's a little bit easier for complicated classes and things like that when you're building up a list of classes for an object, whereas strings are a little bit simpler if you just want this exact class from CSS to be applied to your element. So most of this is almost identically copied and pasted. I got really lazy when I started converting it after typing all the Clojure versions. So you'll see that a lot of the code is really identical. Now, one thing that we didn't do was convert any of these links, and we're going to look at handling links and events in your web app in a little bit. So what we've done is defined an element and called it index. So by using def-lm, that's a function that's provided by Hoplon, and it allows us to create our own little abstracted types of HTML. So what we're going to do is we're going to call this this home index function, and it's going to generate all of this HTML here for us. So we go back to our index page. What we've done is added a link to the new namespace that we just created with that index element, and then we've replaced our div with a call to that index element. So now when that gets updated and we go to our desktop, all the code that was in that home bracket has now been outputted into our body while we're on the index page. Right? Pretty straightforward stuff. I think if you guys have looked at any other JavaScript app before, a lot of this should kind of be ringing some bells. It's pretty similar. But one thing that you probably haven't noticed yet is that our actual index page here is less than 30 lines of code. So this, in less than 30 lines of code, we've been able to create our entire web application template. We've been able to create our home page. We've added a bunch of basic HTML tags and things like that. And we've also handled routing. And I think last time I counted, you're actually able to get to routing in about 20 lines of code, which is a lot faster than in a lot of other applications where you're requiring files, you're importing things, and none of this structure really makes much sense from a programming perspective, right? There's a whole bunch of syntax here and a really important order of arbitrary words and keywords that you don't get when you're in Clojure script, right? The Clojure script alternative to this is all looks identical to the HTML output that you want, right? So it's a lot easier and a lot more convenient when you're programming to work in a single data structure, or in a single language anyway. So we're going to do another time jump here. And really add some more functionality, right? Like all the stuff that we've done so far is generate static code, and we're going to add some reactive functionality to our application. Awesome. So we've jumped ahead in time. Our build, notice that our files changed and it updated itself. And we started getting some errors. So that's because of some functionality that we've automatically just added here. And we'll take a look at that. So what we've done is added another picture namespace as well as the home one. Now, I tried to create this in a format that would mirror pretty closely the other code that you guys are using. Let's see. Can't reach that angle. Okay. So a lot of this is designed, like I said, is designed to mirror your other namespace. So what we did is we imported the data from the data images and the data background and just created two little Clojure lists out of them. This probably isn't the best way to handle these two types of lists and pulling data out of these lists. But what I was going for was code that more represents the JavaScript that is supposed to be in the FreeCodeCamp session, and show you as close as possible the equivalent to that without really getting into the Clojure way of doing things. So our index, or our picture file here, basically just handles a bunch of state changes, right? It handles like some click events, it does some swapping on the state, and then it renders a bunch of changes to that template page that we originally looked at, right? So again, all we've done here is mix a whole bunch of JavaScript and HTML, and from someone who is maybe working on a larger application, or coming into a larger application as an additional developer, it's really hard to really understand what's going on with a lot of this if you don't spend time either from the beginning with a project as it kind of grew, or spend a lot of time learning about just how the project's coded. And it's really difficult to make that transition when you're joining a team. Whereas with our Clojure version, again, all of this is just, looks identical to the HTML output that we're trying to get out of it. So one of the things that this picture page does is it toggles enlarging the picture when you're viewing the page directly. So what we've done is we've created a Javelin cell called enlarge and just set it to nil. And based on that value, we're showing either the enlarged version of the picture or the small version. So you can see the if statement looks pretty similar to a lot of if statements in a lot of other languages. If enlarge is true, it's gonna throw up the first set of brackets there. If it's false, it's gonna throw up the smaller set of image. Now, Javelin cells themselves are what give us that reactive bit of our web app, right? So it handles events, either things like typing into a text box or clicking a button, dragging something across a screen, any type of user interaction with the website. And that's going to change one of our cells and then propagate changes throughout a bunch of formula cells, right? Throughout the rest of them. And we can see that on our next page here. So this one is just, we haven't added any functionality to it yet, so it's just always going to show us the unenlarged version of the application. And we'll go back here. So as you can see, we're still not able to click on anything yet, right? We've copied the CSS out from the original React app, so we're using the exact same CSS for everything. But none of the actual clicking or functionality works. But if we do go to the picture page, it's still not going to picture. I know why. So when you're working with the single page app, everything is on the index page. So you're actually working with you're using the little hashes, right, to indicate that you're staying on the index page, but you're changing a view within that index page. So this is our image page, and again, clicking on it doesn't do anything yet. And our navigation-wise, we have to actually be typing into the web browser, which isn't very effective for users who are trying to navigate your website. So we're going to add some click functionality to this app and make it do stuff. Yeah, feel free. Cool. So we jumped ahead in time a bit. Our project files changed, so it rebuilt. And now what we've gotten, go. Okay, so this has actually updated a bunch of our index page. Home, and we want index. Cool. So what we've done is add a not found element. So this is going to catch all those missing page exceptions instead of giving me those 404s when I mistype something in my browser, or it goes to a page that it can't actually handle as part of the routing. And we've moved routing from the index page into its own app routing namespace. And the reason that we've done that is now different namespaces in our application can kind of pull from the exact same routes and build off of them, so that everything's kind of contextually aware of the exact same pages in the web app and all that kind of stuff. Now let's go to the home page. Cool, and now, oh, we still didn't add event handlers. Cool. So now, when we click on stuff, it is actually changing to the pictures that we want. As well, when we click on the pictures, we're getting that nice enlarge and minify functionality. So go to another one here. Not all of it seems to be loading the image correctly. Right, so most of our web app is giving us the exact same functionality as the React version, and we've done a whole bunch of less code. So we'll take a look at how we actually attach the event handlers to the clicks and all those kinds of things. And it's identical to how we've been setting attributes on the rest of these HTML elements. So if we go to the actual picture page, and scroll down to the bottom here, you can see we've added these attributes, and these aren't real HTML attributes. What they do is they map to the HTML events that the object can output. So every time one of the objects or one of the pictures on the picture page gets clicked on, it's going to swap that enlarge button. Now swap, there's two types of functions that you use on an input cell, and that's either reset or swap. Reset takes the value and replaces it with a new one, and swap takes the existing value and applies a Clojure function to it. So all we've done in this case is take our nil that we defined up here, and we're inverting it with the not function, right? So now when we click on an image, that enlarge is going true, and we're getting the new HTML. And when we click on it, it's swapping back to false, and we're getting the unenlarged version of the image. The exact same thing is taking place on our homepage, where we've now added click events to the different images that we have listed all over our front page. What we've done with those click events is actually passed it back to the Biddy router that we used originally in order to dictate which views that we have, and that will actually generate routes for us for our web app. So all we do is call Biddy, pass in our existing list of routes, and then we tell it which handler we want it to build a route for and what the ID for that handler is. And it's filling in all the data or all the little app points that you need in your routing. So when it goes to the picture, it's filling in that little ID and then generating us a valid route. Does anyone have any questions about the stuff that we've covered so far? I know this is kind of like a crash introduction to it, so it's a little daunting. But most of what we're trying to show here is the workflow for working with Clojure and how you're always working with Clojure. It doesn't matter what you're trying to do, whether it's add click functionality to a website, create some images or add some classes. You're only working with one language, and you're just working with the data types within that language. So as you can see on the left-hand side in our project file, other than the CSS files that we've added, we have maybe 4 or 5 files that have done all the exact same functionality as the dozen files that we have in our React app, right? Not only that, we're no longer just working on raw JavaScript anymore, but it's all been abstracted into this really nice seamless interface in Hoplon. Now, the last thing that I have for us is handling empty state. Now, what we did in our picture example here, we've added some formula cells. Now, this formula cell updates every time we get an ID from that route, and then it pulls the index for that number out of our lists, and that's how it's changing the background as well as the image. This really isn't the best way to be doing this, which is why I kind of skipped over it. But we need a way to handle the empty state, right? Essentially, anytime you go from an image page and you press the back button, your web browser is going to throw an error because the view, even though it's hidden, it just got updated to an empty picture, and it's going to freak out about that. So we don't really want all these errors popping up for no reason in our web browser. And all we're going to do is just wrap a when in front of it to make sure that it actually has a value before trying to calculate the rest of the reactive part of the cell. And then down in our image, we're going to add a little catch so that it doesn't yell at us. So if we inspect this here, as you can see, every time we went back, we were actually getting an error, and it's kind of a, it doesn't really affect the functionality of the web app at all, but it isn't semantically correct. And as well, you don't want a whole bunch of errors popping up in your users' web browsers for no reason. So we're going to do one final time jump here in our project. Cool. That's going to rebuild. And now every time we go back from our picture page, you see we're not getting errors anymore. And all we've done in the actual web application is changed our little picture here to either be the value of that image that it just pulled from the list or be an empty string, right? The web browser can properly handle an empty string. It can't properly handle a nil data value, right? So we basically just pass in an empty string to get around that. And that's what gives you your reactive functionality to your web app, right? Your clicks and parts of the app that actually change. They're just attributes on the DOM elements, and you've never had to worry about working with the events or anything else like that. You just attached them. So that's all that I have for you guys. Are there any questions? I know you came a little bit late, so you didn't really quite get the introduction. But yeah, do you guys have any questions about anything that we covered? No, not offhand? No, that's fine. Awesome. So yeah, feel free to spend the rest of your code camp either working on your own projects or mingling with people, all that kind of stuff. And if you are interested in Clojure, we are running a Clojure meetup in Edmonton now, the Clojure YEG group. Feel free to grab my information from Peter. I'm always around on Slack here in the studio and stuff. And yeah, thanks guys. No problem. Yeah.